Hello everyone, and welcome to the second video in our Netgear router series. In this video we are diving into a vulnerability that allows us to break from a restricted shell. This is a known issue in version 1.0570 and it was reported by NCC Group under the PSV 2023-8. So the agenda for this video is: first, we need to identify the program that handle our request. Then we will extract it from the router firmware in order to reverse engineering it using Ghidra or any other reverse engineering tool. And finally, find a way to escape from the restricted shell. First, a quick recap from the previous video. We saw that by default the Telnet port is not open, but once we send what is known as the magic packet, the port opens up and we can telnet to the device. There are two user accounts. One is user and the other one is admin password. In both cases, there are predefined commands that the user can use. For example, here in this scenario, we see help, logout, exit, ping. So this is not kind of traditional Linux shell. Our task is to break out from this restricted shell. The big questions come to our mind is who is processing our request. The user input, once we type here the command, who on the router side process this request. A quick nmap scan tells us, of course, because this is port 23, that this is the telnet on the router side. So our next step is that we want to obtain this specific version of telnet in order to reverse engineering it. We can do that by going to the Netgear support page. Let me open a browser here. So this is the Netgear support page, and I can type here RAX30 because this is our router. And we obtain here a downloads button. Once I click on it, I see here previous version. We are interested in version 1.0570. Clicking on the download buttons allow us to obtain the firmware. In my case, I already have it on my machine. So once we obtain the firmware, as we can see here, we need to unzip it and analyze it using binwalk. Why? Because I'm interested to know the location of the file system. The file system contains all the binaries, and the one I am interested in, which is the Telnet program. So now I know the file system resides here at this address. Then I can use the dd command to extract it. If you are not familiar with the dd command, it receives as input the firmware image we downloaded. Then we can choose a name for the output, and I skip exactly to the location where the file system there. And once I do that, it will take like a minute or so to extract the file system. I already done that on my machine, so I can now immediately mount the file system I extracted. So I specify this is a squash file system, and I will mount it on the Mint directly. So once I do that, you can see now I have everything inside the file system. I'm interested again in the telnet. So if I bin and then telnet, we see that they have telnetd, and this is at least the program now listening on port 23. If I type the file on this binary, I see this is an ELF binary 32 little endian for ARM architecture, and it's dynamically linked. Dynamic linked is important because we don't know exactly if the telnet itself or one of the libraries it uses is responsible for handling our request. So we can find out also the shared library telnetd uses by running the command readelf, or you can use the ldd command as well. So here we see that there are many libraries, and actually there is no easy way to tell you exactly which library responsible for handling the user input, but from the name here we can infer that, okay, CLI command line interface, that one of them at least responsible for receiving the user input. Just to speed up here, I know now this library is the one that receive our input, our command from the command line and handles it. So that's mean now this is the library we want to reverse engineer. So it's time to fire up Ghidra and reverse engineer this library. I already created a project and imported the library. Once we go inside Ghidra, it asks us if we want to analyze it. I said yes, analyze. You should know that reverse engineering takes patience and careful analysis, but you do not need to understand fully every part of the program. By looking at function names, string references, even logs inside the program, you might be able to pinpoint the relevant code that you need to understand. So that I always keep defined the strings and functions windows open, so I can quickly search for whatever I'm looking for. In this case, I know that the function with name CLI process CLI CMD, this function is the one receives the user input from the command line and processes them. So this is our target for reverse engineering. You can see here we don't have a meaningful name, so that's our task, is to understand this function, how it works, and gives a meaningful name to the parameters. So I already can rename this to user input string. I also, just for simplicity or visualization, I will add ping 127.0.0.1. Let's assume that this is the string entered by the user. Okay, so let's see what the function does. The first thing, the function is compare if this command is equal to net control. This is not relevant to us, but I will name it to flag. After that, the user or the program copies the user input to a buffer. So let's rename this to buffer. By the way, this is not good practice. You should not copy whatever comes from the user to a buffer without checking that the links of the user input equal or less than the size of the buffer. However, this is not related to us now. In the second here, we see we calculating the length of the buffer, but actually this is user input string length. So this is the length of the strings. Ghidra recognize this as current permission. This is referenced in the authenticate function. So maybe that's mean when user logged in, it gets kind of permission. So I will rename it to user permission. Then we have now a pointer to the buffer and our first loop. We need to understand this first loop. We dereference this buffer when we dereference pointer, so that means we are accessing the first letter in this string, and we check if this first letter is equal to space. If not, n is increased by 1 and the pointer is increased by 1. We keep doing that until we reach a space. So in our scenario here, we keep going ping until we reach the space. So what that's mean? That's mean now n is the command length. because that's actually what this while loop is doing. Pointer the command, this is maybe just to understanding, this is, let's call it for now, current character or current char. So now it's more clear. As long as the current char is not space, increase the command links. To just make it clearer, we go back to our presentation. We saw that. Now we are reversing this library, and this is the while loop. Now you see in our example, if we take ping 1 2 3 4, so that means at the end of this while loop the command links is 4. Okay, let's go back to Ghidra. Now we go to the second while loop. First thing we notice that this while true loop, if the condition is not true here, it will goes until flag reach 39, which is in decimal, this is 57. So there is a maximum for this while loop. Here we have a pointer to, well, this is pointer to a data structure in the assembly code. So if we look here, we see a kind of structure here. So here we have a command, maybe here more clearer command, description of a command, and then maybe let me description of the command, and then a calling to a function. This is repeated again here, logout and description, and then call to function. Unfortunately, Ghidra didn't recognize all the commands, so I can go here and I tell Ghidra this is a string, data string. You see this is another command, exit command, data. This is as well a string. We already have seen those commands when we log to the router, if you remember. So I'm just telling Ghidra this is a string. Sometimes Ghidra doesn't recognize everything, so you need to do it manually. Again, this is string. This is the cat command. This is the DNS, and this is the df command. String again. And I think there are more, but for now you got the gist of what I'm doing. So here this data structure point to a table or a list of command. So that's why I will rename it to, let's call it a list of commands. And this is a pointer to a pointer of the list of the commands here. So I will also rename it pointer to list of commands. Okay. We always dereferencing this pointer, and if you notice, like the first one is always a command. So here is a question mark, here is the help. So I will rename this current char. Now I will call it allowed command, and here we are calculating the links of this allowed command, allowed command link. Then inside the if statement, the command links, this is the one entered by the user, compared against the allowed command from the table, from the list of commands. This is the first condition. The second one, if they are the same, so this is, I can rename it to return. So we are just comparing if they are the same. Then we check also the permission. So if you notice here that pointer to list of command +2, it seems something related to the permission of that command. And here we are moving by 2. Remember, this is a pointer, so that means we are moving 8 byte in 32-bit architecture. So now we know that the third component of this structure is the permission. And at the end here, when we move by 4, that means we move to the next struct, not the next component, the next struct in this list of command. Maybe to make it a little bit clearer, this is in C, you will make it something like this. So this is command struct, which has all this component, char name, char description. Then we have 1 byte for permission, 1 byte for lock. We will see how we determine that. Then 2 fields, I don't know about them. And then we have a call to a function that, let's call it here, execute. Let's go back to Ghidra. That's exactly what you see when we see this list of command. By the way, here it seems also Ghidra didn't recognize, but we know that this is a pointer, so I will call it this is the same one, or this is the different. So 1, 2, 3, yeah, this one here. Okay, this is a pointer. Okay. And because I know this is from help, this function, I can call it process help. Okay. Because as we said, after each last point is always, you see here in the structure, we have help, then call to help, we have log out, then process log out, the same for quit, process quit. So this is how the data structure. Let's create this data structure. I will go here, new, and then I will take structure. Let's call it first command struct. The first one is char. This is the pointer. The next one is char as well, pointer. Then we have byte 4 times. And then here we have, this is a call to a function. So I will call it void pointer. So let's name description. Then we have permission. Let's log. We know it already. Then here, let's call it execute. Okay, so now we have our struct. I will save it here. What I will do now, 2 things. So we know now this should be of type command struct. So I will retype it here. I will choose command struct, the one we created, and this is a pointer. Notice now when I hit OK, you'll see the difference here and here. Okay, so you see now it's access the field of this struct. So now the name, compare it against the allowed command. Here the permission is the same with the permission, and here move by 1. So that's mean we move one struct. I will do the same, but now for the global variable here. So I come here and I will right click, then data, and then use the T. And again, I will change it to command struct. Okay. It asks me, are you sure? Because it will override. I said, yes, we are sure here. And let's see, we open this one, and now number 1 is name the command. Then we have a description, we have permission, we have log, we have 2 field, and we have execute, which is calling the function process help. I could do the same for this one. I press T and command this one. Are you sure? Yes, I am sure. Again, I will get the same. Let's do another one. This is the log out, T command. Yes, this one. Yes, I am sure. And yeah, we can do all the command here, but now you understand what we are doing here. I think now this loop is more clear to us. So it takes the command coming from the user, it compared the links first, the links of the command coming from the user. It's compared to the links of the command coming from the list of allowed command. If they are the same and the permission is okay, so that means the user has the permission to execute this command, it will include this flag. Let's rename it to, now this is command index, because here we are looping through the list of this command here. Increase the command index by 1 and jump to the next command if their conditions are not met. Then once we identify a command, the loop breaks and we go outside here. So now it check if the command it's assigned to the user permission. If the user permission or the lock is 0, now acquire lock on this, compare it to this one. If it's okay, then check this condition here. What's happened now here? We go to the list of the commands based on the command index, the one we got it from the loop. And now we check the execute component of this struct. If the execute component equal to 0, so that means there is no function call there. If this is equal to 0, run the command entered by the user in the shell. You see what happens here? There is no validation on the command entered by the user, because remember, buffer, we copied, where is buffer? Here. We copied what the user input to the buffer, and then we use this buffer. Let's highlight the buffer. We use this buffer to execute, or the command in buffer to execute this command in the shell without any validation. Now what we need to do, we need to check for a command that the execute is equal to 0. Let's go to the list of the commands here. So the help doesn't work because we have a call to help. The logout doesn't work because we have a call to logout. So we go through all of this, and until we reach, I think you should have guessed it, until we reach the ping command. Where is the ping command? That's why I use it as our reference here. Ping command. Let's do the same what we did. T and then command. Yes, this one I want. Okay, yes please. And now I have the ping command. And what you notice here, execute is 0. Okay, so what that means now? If I type the ping command, then semicolon, and then give another command, because there is no validation, that's mean I will execute a command I'm not allowed to execute. So let's see that in action. I want the PyCharm. Maybe let's close Ghidra for now. So here, on the right here, I will use PyCharm to send the magic packet and open the Telnet port, and here we will log into the Telnet. So let's do that. I will send the packet, and then here user and help. I am in the restricted shell, so now let's call ping-c. I just need 127.0.0.1, and then semicolon. Let's call bin sh. And see, we are now inside the shell. So you name -a. Now I can use more command. Let's, I don't know, let's -l. Oh, you see, now I am inside the complete file system here. So let's go back to the presentation. Yeah, we have seen that. Then we created our struct. That's how the ping command is organized, and you see there is 0, so that's meet our condition here. and then we establish ping-c, and then as you have seen now, we escaped the restricted shell. Maybe this was a longer video and I was not sure if I should go more in details on the reverse engineering part, but I hope this gives you kind of understanding of real scenario examples, how they found a vulnerability, how they write the exploit or take advantage of these vulnerabilities, because this is a real world example from Netgear routers. So thank you for watching now, and see you in the next video. Bye bye.